50 years. Half a century since humanity last left a boot print on the dusty surface of the moon. The iconic images from the Apollo era of astronauts planting flags and bouncing in low gravity have become relics of a bygone age. For decades, low Earth orbit was our boundary, the International Space Station our furthest outpost. But the long silence is about to be broken. A new generation is preparing to answer the call of the cosmos, to write the next great chapter in human exploration. This is the story of Artemis II. The Artemis program, named after Apollo's twin sister in Greek mythology, is NASA's ambitious plan to return humans to the moon, this time to stay. It's a multi-stage endeavor, beginning with the uncrewed Artemis I mission that successfully tested the hardware in 2022. Now, the stage is set for the first crewed flight, Artemis II, a mission that will carry 4 astronauts further into space than anyone has gone since 1972. At the heart of this mission are 2 technological marvels. The first is the Orion spacecraft, a state-of-the-art crew capsule designed for deep space travel. It's our lifeboat, our science lab, and our home for the 10-day journey. The second is the Space Launch System, or SLS, the most powerful rocket ever built. Its sole purpose is to provide the colossal thrust needed to break free from Earth's gravity and hurl Orion towards the moon. The Artemis II flight plan is a daring orbital ballet. After launching from Kennedy Space Center, the Orion capsule and its crew will orbit the Earth twice, testing its systems and gradually increasing its altitude. Then, the rocket's upper stage will fire, beginning a 4-day coast to the moon. Instead of landing, Artemis II will perform a lunar flyby, swinging around the far side of the moon, a place no human has seen with their own eyes since the Apollo missions, and using the moon's gravity to slingshot back towards Earth. This free return trajectory is a critical test of navigation and a crucial safety measure for future missions. And who are the pioneers undertaking this historic voyage? 4 of the most experienced and dedicated astronauts in the world. Leading the mission is Commander Reed Wiseman, a decorated US Navy pilot and a veteran of the International Space Station. He's known for his calm leadership and deep technical expertise. At the controls as pilot is Victor Glover, another Navy aviator who piloted the first operational flight of SpaceX's Crew Dragon. His experience on the ISS makes him uniquely qualified for this long-duration test flight. Rounding out the crew are 2 mission specialists. Christina Koch is an electrical engineer who holds the record for the longest single spaceflight by a woman, an incredible 328 days. Her endurance and scientific acumen will be vital. And representing the Canadian Space Agency is Jeremy Hansen, a former fighter pilot and the first non-American to ever leave low Earth orbit. His inclusion highlights the international collaboration at the core of the Artemis program. Together, these 4 individuals form a team ready to push the boundaries of exploration. Originally slated for late 2024, the mission was delayed to 2026. This wasn't a decision made lightly, but one driven by an unwavering commitment to crew safety. 2 key technical challenges emerged during post-flight analysis of the uncrewed Artemis I mission. First, the heat shield on the Orion capsule showed unexpected and uneven erosion of its protective charring layer during re-entry. This layer is designed to burn away and carry heat with it. But engineers needed more time to understand exactly why it wore away in an unexpected pattern to guarantee it would protect the crew on their much faster return. The second issue involved a critical component in the life support system. During ground testing, valves that control the flow of air and remove carbon dioxide from the cabin failed unexpectedly. In the unforgiving environment of space, a reliable life support system isn't just a feature, it's the most fundamental requirement for survival. NASA's philosophy is simple: fly when you're ready, not when the schedule demands. The delay ensures every system is understood, every risk is mitigated, and that Wiseman, Glover, Koch, and Hansen have the safest possible ride. While Artemis II won't land, it paves the way for the missions that will. The data it collects on the spacecraft's performance, the crew's response to deep space, and the accuracy of navigation will be indispensable for Artemis III, the mission that will finally see astronauts, including the first woman, walk on the lunar surface once again, this time near the moon's south pole. But Artemis isn't just about planting flags and leaving boot prints. The ultimate vision is a sustained human presence on the moon. This includes building the Artemis Base Camp, a permanent outpost where astronauts can live and work for extended periods. It will feature a modern lunar cabin, a rover for exploration, and a mobile home, allowing us to study the moon's resources, like the water ice hidden in polar craters. This lunar settlement isn't the final destination, it's a critical stepping stone. Living and working on the moon will teach us how to become an interplanetary species. We'll learn how to use local resources to produce water, oxygen, and rocket fuel. We LL test the technologies and strategies needed for the next giant leap in human exploration, sending the first astronauts to Mars. The journey to the red planet is a multi-year marathon, and the moon is our training ground. Artemis II is more than just a single mission. It is the bridge between the Apollo generation and the Mars generation. It's a testament to human ingenuity, perseverance, and our unyielding desire to explore the unknown. When that SLS rocket ignites and climbs into the sky, it will carry not just 4 astronauts, but the hopes and dreams of an entire planet ready to reach for the stars once more.